You go to bed early?
I don't have too much to do. Never can.
What do you have to do?
School stuff. What else?
What do you do? Assign less stuff.
Oh, no, that's not enough.
Yeah.
No, that doesn't
Mr.
work.
Roy, I have an argument. If you get an A on your test but you don't turn in your homework, should you have to do the homework?
Yes.
It
It
shows
for the test.
participation.
But the homework is practice for your test.
Participation in like, how the heck?
You know what?
Okay, so in all honesty, I am somebody who kind of would lean towards the notion that I think, I'd be fine if you did well on your test, but that's not the way, it's not our policy. Although in college, it's more that way, for better or worse. In college, you're likely to take some, in most of my math classes in college, in grad school, we do homework like this, the professor would just kind of say something like, here's like 60 problems you gotta take a look at. Be prepared to do these problems, that's what I think. And then you don't get any credit for them, but you just, you just have to go do those problems.
I think it should be optional though. Like if you need extra help,
Like the
with
informal assignments?
Yeah.
So which is really, it's a great, I like that notion in a way because it gets at the whole point of this, which is a learning material.
Yeah.
A lot of people really don't get stuff for just like turning in an assignment. The assignment doesn't mean very much other than practice. Now, being able to demonstrate it on a test, on the other hand, is kind of a big deal, because you're showing that you know how to do something, right? So, yes, so I would philosophically agree with you, but just not an option for us.
Personally,
Yes.
he hates
Also, something to add on that, homework is also used to show the teacher and the district that the students know how to do the work they're being taught by teachers, which ensures the teachers are doing their job.
There you go,
You just lay down the facts.
there you go.
But you could also like use online help, that's not the teacher helping with homework.
Yeah, Google.
But you're not really like actually
Not your
learning,
class,
though.
but
You're just
your way
reading an article that's giving you information that you probably don't understand.
I would be honest.
Yeah, your
with
question
Which is a teacher's job.
Yeah, especially with math, it's kind of, there are people that learn, you could learn math, but it's just hard to do if you don't have somebody that knows how to do it to kind of guide you along the way,
Yeah, and this has been hard for the first people who decided to do that.
No,
I mean,
they
it's-
decided to do whatever they wanted.
It is, I've
Very first
people-
learned plenty of math on my own, and it's
Just
hard to
started
do it.
writing
It
numbers.
really is. Honestly, I think one of the best things, one of the things that I try to do that helped me the most, going all the way through my whole academic career, is just being around people that could just communicate what they're thinking about how to do it. Like listening to somebody that knows how to do something, describe how they're doing it, and kind of giving you insight into how they think about it is the best way to figure it out. Because you really, what do in life when you want to do something? You try to replicate what people who know how to do it do. You copy them, right? And you try to, literally, that's what we do. We try to replicate what people do who are successful with something. We try to say, I want to be like that, so I'm going to try to develop those patterns, right? Okay, so that's a lot of what teaching is just demonstrating how do you do this stuff the best way, correctly, right? Okay, so anyway, use Desmos to fit these curves. There's a really slick and easy way to do this on Desmos. So pay close attention, because this is your friend. This is going to make life easy. So we talked yesterday about how if I've got a line, 2 points defines a line exactly, right? There's two parameters in the line, m and b, slope and y-intercept, that we need to be able to fill in, and we use the 2 points to get at those things, right? So in Desmos, you can use something called regressional analysis, which has other purposes which I'm not going to talk about right now. I'll just hint at them. But if you click on the plus sign up here, you can add an item. We want to add a table. Okay, so in our table, we're just going to add the x and y values as ordered pairs. So I've got the x value -6, and with that is the y value -6. So there's my ordered pair. Just imagine that we've got those in parentheses. That's an ordered pair. I'm just hitting tab to go from place to place. So then I get the ordered pair 2, -10. Okay, now watch this. I've got all that stuff in there. If I go down to the next row and I do y1, so you type a y followed by a 1, and then you're going to use a tilde, this thing right there, which is above tab to the left of the 1. That means is approximately equal to, or is approximated by, and then I'm going to type any form I want to. I'm going to type m x1 plus b. Now look what it does. That's pretty cool. It gives me the answer. It's telling me that the parameters are m equals -5 and b equals -9. Yes, ma'am.
If you wanted to, could you use y2 and x2? Or is it just use?
No, we have to use whatever's, this table uses x1 and y1. So if we did another table that was x2 and y2, yeah, you could do
Oh, I
that.
thought that correlated with each, okay.
Yeah, I thought you would
Order
negative
pair.
X2.
So it's, all that means here is because these are specific x values that go in this table. We're calling this column x1 and that column y1. I could do another table where I had x2 and y2, and maybe I want to do like a different line using this curve fitting technique, right? And then I could do y2 is approximated by mx2 plus b, and I get a different line. In Desmos, not only does it give you the answers, meaning, that help if I make it a little bigger, I guess. Not only does it tell you what the equation of the line is, it actually plots the line for you, which is kind of cool. And look, those are the 2 points that we used. Pretty cool. Now I want you to notice something. If there's 2 points, the line goes exactly through those 2 points, doesn't it? Watch what happens, though, how I can ruin this if I add a third point. So what if we add the point something like, how about -10, 1? What do you notice now?
It's not an answer.
Yeah, good. It's the line of best fit. But typically, if I have more than the minimum number of points needed, which is 2 for a line, the line of best fit is very seldom where all 3 of those points going to line up on exactly a line. 2 points always line up on a line because 2 points define a line, right? So if I put in 3 or 30 or a billion points, it's unlikely they're all going to be on the line. And so what the regressional analysis does, the math gods sitting there helping Desmos out here, they just figure out what is the equation of the line that best fits those points based on the statistical procedure called regressional analysis, which is all it is. It's a least squares mean fit is really what it is. But we're not going to go into that stuff. But it's the sort of the accepted standard, among mathematicians and statisticians for being, the most useful kind of finding a best fit line. It does tell us what the values are for that, though, which is pretty handy, right? So if we've got 3 data points and we want to find the line that best fits the data, there it is. It's the line that has a slope of -0.857143, blah, 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 and b is -9. Okay? Right? So, but once again, our point here is we want to find an exact fit, so we're only going to use 2 points. Okay? How do we do this? Let's go to the next, so that we got the answer we got yesterday, which is negative. Now we want to write this in exact form. I've got -0.5 is -1/2. Here, let me take a picture of this thing. How about? So what's this telling us then? Just a quick reminder. This is telling us that the answer is so the answer is, from right here, the answer is y equals -1/2 x minus 9. Right? So that stuff right there is just telling us that. Yes.
Will we have to know how to do that without Desmos?
That's what we did yesterday.
That's what we did yesterday.
So it's just like,
So there's going to be two tests coming up for this unit, right? There's going to be a unit where you have, or a test where you have Desmos and a test where you don't.
so it's like x2 minus x1 divided by y2 minus y.
Well, it would be, yes, remember what we did yesterday is we calculated M and then we solved for B by plugging in a solution. Right. Oh, the video's up.
Oh, yes.
Yeah. Okay, so let's do another one. Okay, so same exact problem we did yesterday. Let's use Desmos, though. right? So in Desmos, right? So in Desmos, we can get rid of that. So what are our points here? We got 2, -3, 3, -6, 4, -11. So there's my 3 points. 3 points exactly define a parabola, just like 2 points exactly defines a line. There's only one parabola that's going to go exactly through all those 3 points. And the way we find it is to do the same sort of thing. Now, we want this one in standard form, or general form, right? So we're going to do y1 is approximated by ax1 squared plus bx1 plus c. What do you know? We get a perfect fit, right? And the values of a, b, and c are -1, 2, and -3. Exactly what we got yesterday. Okay, so take a picture of that. Oh, darn it. No, that's pretty cool, I think. You can see how and that's how you do math in real life. That's what you would do for this.
You don't get to use your cool highlighter trick to use smart.
I know, that's kind of. I need to find more uses for the highlighter trick because I just really like doing it.
Use the highlighter.
So this, no, it's not really called for, right? So that stuff is just telling me that f of x or y, whatever you want to call it, equals -x squared. I guess we didn't do this one yesterday. Plus 2x minus 3. We didn't do this one yesterday because we really can't do this one without technology, right? This is one where, I mean, we could, but I'm not going to show you how. You have to end up solving a 3x3 linear system. We don't. There's no magic silver bullets up here. None of those points give us any of the parameters for free. Like yesterday, we had points that corresponded to P and Q, or H and K, that we could just immediately write in there. We had one leftover point to solve for A, right? This one's not that way, but Desmos makes it pretty easy. Now, the nice thing about this is, watch this. This is even cooler. In Desmos, what if I wanted to get that one into, let's say, vertex form? That's easy to do. All I've got to do down here is when I'm typing out the equation that's approximating the data, I would just do A times the quantity x1, it's got to be x1, minus h squared plus k. What do you know? It tells me exactly what the values of A, H, and K are for the points that go exactly through, the parabola that goes exactly through those points. Okay? This, just another little, you guys are here a little ahead of the game here, 7th period, one more little thing. The r squared up here, notice the r squared is 1. Watch what happens if I screw this up by putting in a 4th point. Like, let's say I'm going to put in the point 0, 0. Okay, so now those don't fit exactly, right? They don't fit exactly, and I know that because look at the r squared. The r squared is less than 1. Think about that like a percentage. 1 is equivalent to 100%. This is like a 99.88% fit. So those points are pretty close to one exact parabola, but they're not exact. If I zoomed in, I would see that those points don't sit on that parabola. They just sit very close to it.
Would it be the
Okay.
same if we did like 1, 1 or something else?
What do you mean?
0, 0.
Well, I could make it a lot worse. Like here, I'll give you a like, what if I pick a point that doesn't fit very well? Like, what if I picked a point like 10, 10?
Okay.
Now, those don't fit as well. So look what happened to the percent fit. Now it's only 98.98%, right? Or if I pick a point like, what's even worse than that? Like if I pick a point like,
24 and -5.
what if I do over Oh, I know, here's a horrible one. What if I do over 2 and up 10? It's not gonna like that at all. Right?
16%.
Yeah, that's a pretty bad fit right there. Okay? See what I'm saying? Okay? You just play this stuff all day. It's pretty fun stuff. Okay, one more. Okay, so here's one that's in, oh, I know what one I want to do. So this one would be no big deal, would it? I just type in those 3 points. Those are going to come up as x-intercepts, right? What if I do this guy, though? This is a tricky one. I need to have 3 points. If I try to do, watch what happens here if I try to do regressional analysis on this one with only 2 points. So let's put in those 2 points. Let's put in the points -5, 16, and -13, -48. And if I try to come down here and do regressional analysis,
Use the vertex.
okay, it's going to break things. Did that work? What the, no, it didn't work.
I'll put it in first, okay?
5, 16, -13. So there's a point. That's pretty cool. I can't believe it did that.
That's like a chance.
It's really weird to me that it did that. Yeah, it's got the same thing.
First time about Amber Alert.
Well, you know, Amber Alert's not a stolen car.
Amber Alert's a kid.
It's a kidnapped kid.
Oh.
Yeah.
Oh man, I've been ignoring all these.
Someone got kidnapped. Someone didn't have to.
Okay, that's a little weird to me that it did that. That's kind of strange. I think this is a little flaw in Desmos because there's no reason that couldn't have been that this couldn't have been the vertex too. Just want to see what happens if I flip these around.
It's like fixing your mistake, thinking for itself. Whoa.
It's like
That's a lie.
your computer just needs up and search
And what was the other point? Oh, negative.
-5.
I can't do that because there's no way that it knows that that's the vertex.
They really updated it.
What's the?
They can't because I should just as easily be able to draw a parabola that goes like this. Okay, so that's a little flaw in Desmos. Desmos shouldn't have done that. It shouldn't have given me back an answer for that parabola. I can't guarantee that it's right. I need to have 3 points, right?
So
But here's the thing though, I get a free point. Because if I'm told that this is the vertex, right? If I know that that's the vertex, then I also know that I've got folding symmetry over that line. See what I'm saying? And so to get from the vertex, and let me go ahead and,
Wait, pick a random point and see if this is, oh, this is just a point.
right?
Yeah, try that one.
But here's my point. If I do this, let's make this thing bigger. Right, if I graph the line, while we're at it, let's graph the line x equals -5, right? So then I know that, would you guys agree that if this is the line of symmetry, there's got to be a reflected point right there?
Yeah.
So if I know that's the vertex, it defines where the line of symmetry is, then there's got to be a reflected point right there. Well, where's that point going to be? That's easy to find. It's going to be just as far to the right of that line as the green point is to the left, isn't it? Right? So if we were gonna come down here and and we don't have to have a graph, we could just figure this out on pencil and paper. But what's that distance, right? If I find let me put in some coordinates here, so we got negative, can't read this, negative 13, whoops, comma, negative 48 shows up right there, right? So this is the line, right here, this is the line x equals negative 5. So what's that distance? From negative 13 to negative 5 is 8, right? So if I go 8 to the right from there, I should get positive 3. So I know that the other point should be positive 3, negative 48, shouldn't it? Same y value, just reflected x values. So I should be able to go back up to my table up here.
Doesn't it matter which one you use?
It does, because we have to use the vertex, we have to use the one that's not the vertex. The vertex reflects onto itself, but the other points reflect onto a different point, right? So what did we say that was? It was going to be positive 3, negative 48, right? And now we get the right answer, right? Now we get that, okay?
So I just don't understand why it has to be negative 13, negative 48. Why couldn't it be then 3 and negative 48? For the third
For the third ordered pair, because it has to be the reflection over the line of symmetry.
Yeah, so why couldn't it be the other one? The 3, negative 48.
I don't understand the question.
Yeah, like, why couldn't it be that dot way over right there?
Mm-hmm.
That one, it's like the same kind of, they're the same reflection, so why couldn't it be that one?
That was given to us originally?
That was given to us?
No, but these are the two that were given to us in the problem, so we have to come up with the other one that's not given to us. That's
So, I mean, you use the 3, so why couldn't you do negative 13 then?
I
Oh,
did.
use 3. I don't know.
Right.
Never mind.
Well, I mean, there's the original problem, right? So they gave us the vertex, and they gave us this one other point.
Okay.
See what I'm saying?
Oh, yeah.
And so, being as they gave us that one, the missing point was that one.
Yeah, you got me.
Okay, make sense?
Wait, couldn't you just use couldn't you just use the point to find the other one? Instead of having to do all of that?
What do you mean?
Like, go back to the question. It says, parallel with vertex passes through the point, negative 13, negative 48.
Mhm.
Couldn't you just use negative 13, negative 48 to find the point?
You could. That's what we did yesterday. Yeah, you could do it algebraically, but I'm saying if you want to use technology, you technically you need to have those 3 points. Right, so
Brandon's asking all these questions and he's getting the answers and he wasn't here yesterday.
okay, so even though I mean you get what I'm saying, that Desmos kind of screwed that up. It really shouldn't have given us this answer when I put in those points, because what if the problem had said instead that that's the vertex and that's the other point? Well, Desmos just assumed that was the vertex. It got it 50-50, it got it right, but it might have gotten it wrong.
Your
But-
FBI agent
The one
did
that
a step
sent
for
through
you.
your thing, assigned
Yeah.
to you?
You know, the deaf guy agent assigned to Tyler.
Yeah,
They're laughing.
yeah. And so that's why we had to add a third point, so we could specify then. We knew, Desmos, the math gods knew if I added that other point, 3, negative 48, aha, that makes that the vertex then. It's only the only point it could be when I have 3 points. Okay, you get the idea? Okay. I think that's good for today.